Okay, good morning. So let's get things started. So last time we briefly started section 3.3, okay, which was about zeros of polynomial functions. Okay, so like I said at the end of last class, so this is, I believe, one of the most difficult sections of the course because there are lots of technical things in this section, and also there are lots of important stuff. Okay, so we will see four big theorems. Okay, remember. And here is the first theorem, which is called the factor theorem. Okay. So what the factor theorem says is x minus k is a factor of f of x. So that means f of k is equal to a 0. Okay. So that means, in other words, k is a 0 of f of x. Okay. So now remember, this is actually what we have stated at the end of section 3.2 last time. Okay, so here in this big box of the several important facts, I said k is a 0 of f of x, and that's same thing as x minus k is the factor. Okay, so there we go. Okay, so it's nothing new. Okay, and here what you have to be careful is when you get a factor of a f of x, you have to subtract your 0 from x. Okay, so it's x minus k, not x plus k. Okay, and remember k is the word 0, not the number 0. Okay, so a few extra notes about this theorem. So x minus k is an example of a linear factor. Okay, so when you do your homework, you will see the term called linear factor several times. Okay, but that's not the only linear factor. The linear factors in general have the form mx plus b. Okay, so that's what linear factor means. And you can see why it's called the linear factor, because this mx plus b is called the slope-intercept form, which makes sense for a line. Okay, so it's called linear factor. So whenever you see the word linear factor, it means there is no higher powers of x, like x squared, x to the third, and so on and so forth. Okay, so you only see x to the first power. Now, finding the correct k is the key. Okay, so now what does that mean? Remember, k is the 0. Okay, so k is the 0. So you have to find the correct k such that f of k is equal to 0. Okay, so you plug in that number into x and you get equal to 0. So once you find k such that f of k equals 0, in other words, k is a 0, use the synthetic division. Use the synthetic division to further reduce the exponents and also to find other zeros. Okay, so last time when we covered the synthetic division, we saw that once we apply the synthetic division, the powers of x are decreasing. Okay, so that's why we apply the synthetic division to reduce the exponents. Okay, now keep applying this synthetic division. Keep applying this synthetic division until you reach the quotient. Remember, that's the notation for the q of x, to be a quadratic expression. Okay, such as when we have something like this. Okay, so now why do we want to go until the quadratic expression is, or the quotient is the quadratic expression? because once we reach the quadratic expression, we can factor q of x, okay, if possible. Okay, so for example, if this were Q of X, and you can verify this if you want, you get the quotient to be x minus 1 times 2x minus 1, okay? And what's the significance of each of these two factors? They are linear factors, right? Okay, so basically, once you reach the quotient to be the quadratic expression, you can see if you can factor the quotient without applying the synthetic division once again, so that you can get the linear factors, okay? And for some problems in the homework, you will see the word factor completely, okay? So that means factor f of x into linear factors, okay? So that's what it means. Okay, so that's first page, and now I'll go to the second page. Okay, so so first problem, determine whether x plus 4 is the factor of f of x. Okay, and you have two functions. Okay, so now obviously the answer to each part is yes or no, okay, because you have to ask whether x plus 4 is the factor or not. Now, yes, you have 50% chance of getting it right, but at the same time, you have 50% chance of getting it wrong, okay? So let's try to use math, not any guess, not any guessings to deduce the answer. Okay, so here, what do we first have to do? Okay, so whenever you see f of x, and from now on, of course, and whenever you see like this x plus 4, which is a linear factor, the very first step that you have to do is apply the synthetic division. Okay, so apply the synthetic division. Okay, now, based on what we did on Thursday, this f of x is usually the dividend, right? Okay, so that's the dividend. Okay, and remember for the dividend, what we do is we take all the coefficients, right? Okay, and of course we cannot miss any exponents. Now, here there's no divisor. So are we in trouble? Well, not really, okay, because based on how the problem is written, that seems to be the divisor, right? Okay, and remember what do we do for the divisor? We set it equal to 0 and solve, right? Okay, so we get -4. So for f of x, we take coefficients. So first we write 3, okay? And be careful, we don't write -48 next, right? Because there's no x cubed, okay? So what you have to do is put 0 for x cubed, and then -48, and then 8, and then 32, okay? So remember, that's important. And then put this open rectangle or half rectangle, okay? And then the outside, we write -4, okay? And now remember, when I did the synthetic division in 3.2, I kept labeling that outside number as k, okay? So now what do we do? So first bring down the first number, 3, and then we multiply these two numbers, which is -2, and then we write it right below 0, okay? And remember, for the outside, we have addition. Here's this big addition sign, okay? So 0 plus -2, so that's just -12, right? And then that times that, so that's +48. And then we add -48 with +48, so we get 0. And then multiplication, so that's 0, addition 8, and then multiplication once again, -32, and then addition, we get 0. Okay, so that is the end of the synthetic division. Now, what is the significance of, okay, so here, let me put it this way. What is the most significant number? The most significant number is this one, okay, which is what? The remainder, right? Okay, so now the remainder is the most important number here. Why? Because let's go back to this thing in 3.2. Okay, so now when the remainder is equal to 0, so what does it mean? Okay, so this means all of this, but in particular, k, which was -4 in this case, is a 0, and at the same time, x minus -4 or x plus 4 is a factor, right? Okay, and remember, whenever we applied the synthetic division and 0 was the remainder, we were able to factor things, although we didn't mean to. Okay, so from here, since 0 is the remainder, we know that x plus 4 is the factor. Okay, so what does that mean? If the remainder was not a 0, then it's not a factor, right? Okay, so 0 remainder means yes, it's the factor. Okay, and like I said, -4 is a 0 as well. Okay, so now your f of x changes. So now it's x to the 5th plus 6, that's x to the 4th, and so on and so forth. Okay, so step number 1, same as before, synthetic division. Okay, so now synthetic division. So f of x is the dividend, okay, same as before. So we take the coefficients. Okay, so what does that mean? 1, and then 6, 11, 12, 5, and -20. Okay, and then since our divisor, which is x plus 4, doesn't change, we write the same number outside, which is -4. Okay, so we write -4 here. Okay, so now do the division. So bring down the 1. Okay, multiplication, so that's -4, and here's the addition outside. Okay, so 6 plus -4, that's 2, and then -8, and then 3, -12, and then 0, 0 once again, 5, -20, okay? And now, -20 plus -20, okay? So that's not a 0, remember, right? Okay, it's not a 0, it's -40, right? Okay, so in this case, which number are we looking at? That number, right? Okay, so here, what do we conclude? X plus 4 is not a factor because the remainder is not a 0. Okay, so that was the remainder, remember? Okay, so that's how we know whether something is a factor or not. Okay, so we just apply the synthetic division to the f of x, and then with the correct choice or the correct value for the k. Okay, so now that's number 1. And then number 2. Factor each f of x into linear factors. And remember, I just said a few minutes ago that that means factor completely. Given that each k is a 0, and then find other zeros. Okay, so now if you read this problem carefully, it's consisted of 2 parts. Okay, so number 1, you have to factor f of x completely. Okay, so that's the first task. And then task number 2, you have to find other zeros. Okay, so here, what do we do first? Okay, so now for the previous 2 problems, the first step was the synthetic division. Okay, and it's actually same thing here. Okay, so step number 1, the synthetic division. Okay, So now here, what is the dividend? The dividend is always f of x. So that's the dividend. Okay. So for the dividend, what do? We take the coefficients. So we get 6, negative 37, and then 32 and 15. Okay. And there's no missing powers of x, right? So we just don't write 0 here. Okay. And then put this half rectangle. And now here we don't have the divisor. Are we in trouble? No. Okay, why not? Because even though we don't know the divisor, what do we know? The k value, right? Okay, so we write 5 outside. Okay, so do the division. So bring down the 6, and then positive 30, and then once we add, we get negative 7, negative 35, and then negative 3, and then negative 15, and then we get a 0. Okay, so now we know 0 is the remainder, but is it surprising? No, why not? Because what did the problem say? Each k value is a 0. So what does that mean? 5 is a 0. So of course we should get a 0 remainder once we apply the synthetic division. Okay. So that's not surprising at all. Okay. So instead of looking at the remainder, what do we look at instead? We look at the quotient. Okay. So here, what is the quotient? The quotient is 6x squared minus 7x minus 3. Okay, remember for the quotient, we decrease the exponent by 1, right? Okay, so here it's like x cubed, x squared, x and number. Okay, so that will be x squared, and that will be the x, and that will be the number, right? Okay, so that is the quotient. Okay, and now what do you notice here? This is the quadratic expression, right? Okay, so like I said on the previous page, whenever you get a quadratic expression, you have to always ask yourself, can I factor this? Okay, so let's see if we can factor 6x squared minus 7x minus 3. We don't know, okay? We don't know if we can factor it or not. So let's see. Okay, so let's see. Here the sum is what? Negative 7, and the product is negative 18, right? So what are the two numbers? Negative 9 and 2. Okay, so now what do you do? Okay, so here you can use either AC or the so-called Mustang method or whatever. But if you use the AC method, so what do you have? 6x squared minus 9x plus 2x, and then minus 3, right? And then you do the grouping. And from the first group, the GCF is 3x. And then from the second group, the GCF is 1. Okay, so, so what you get is 3x times 2x minus 3, and then plus 1 times 2x minus 3. Okay, so you get 3x plus 1, and then 2x minus 3, right? Okay, so what do you notice? So that's the quotient function, q of x, right? Okay, so indeed, we were able to factor q of x. Okay, now, is that it for the problem? And the answer is no, because yes, we factored the quotient, but is that what we have to do? No, we have to factor f of x into linear factors. Okay, so now where do we go from here? Now where do we go from here? So let's see, let me see if I can find that particular fact which was on the previous section. There we go. Okay, so last time, remember, we had this fact. So when we divide f of x by x minus k, we get a quotient and the remainder r. And so we have this. The dividend is equal to divisor times the quotient and plus the remainder at the end. Okay, so how can we apply this fact to this problem? Okay, so we have f of x equals x minus k times q of x plus r. Okay, so what does it mean? What is x minus k here? So since k is equal to 5, x minus k would be x minus 5, right? Okay, and then what's the quotient? The quotient was 6x squared minus 7x minus 3. Okay, but we have factored it into 3x plus 1 times 2x minus 3, right? So we have 3x plus 1 times 2x minus 3. Okay, and now what's the remainder? The remainder was 0, right? Okay, so that is gone. Okay, so we have x minus 5 times 3x plus 1 times 2x minus 3. And now, what do you notice here? Have we factored f of x into linear factors? Yes. Okay, do you see that? Because each of these three is a linear factor. Okay, and there's no remainder at the end. So although we didn't mean to factor f of x, somehow we factored it. Okay, so that's the answer to the first part. Okay, so now part number 2. How do we find the other zeros? Okay, so now remember, again from the previous section where we had this fact here. So what did we say? 0, the word 0 is same thing as the x-intercept, right? Okay, and now how do you find x-intercept? Set y equals 0, and y is same thing as what? F of x, right? Okay, so how do you find the zeros, which is same thing as the x-intercepts? Okay, so to find zeros, you set this whole thing f of x equals 0. Okay, which is exactly the same as finding the x-intercept. Okay, so you get x minus 5 times 3x plus 1, plus 1, and then times 2x minus 3 is equal to 0. Okay, so now what do you notice here? You multiply three things and the answer is equal to 0. So that means what? One of them has to be a 0, right? Okay, so that, and that. So what do you get? X is equal to 5 from here. And then from here, you get negative 1/3. And then from here, you get positive 3/2, right? Okay, so is this the answer? And unfortunately, no. Okay, why not? Because look at the problem carefully. So what did the problem say? Find other zeros. Now, why did it say other zeros? Because one of them is given, right? Okay, so what should be our answer? So that is the given 0, which we knew from the beginning. So the answer is just these two. Okay, so there are lots of tricky things here. Okay, so first we applied the synthetic division, and then we got the quadratic quotient, which we have factored it. Okay, and then we have used this fact, and I told you that we will revisit this fact like 1,000 times in the future, and here it comes once again. And then we were able to factor f of x completely. And then to find the zeros, we set each factor equal to 0, but we have to remove one of the zeros because it was already given. Ooh, okay. So now, that's part A. And now, part B. Okay, so here is part B. Okay, so now our f of x changes, and then the value of k is also changes, okay, or is changed, it's different. Okay, so now here what do we do? Okay, so remember f of x is always the dividend. Okay, so step number 1, synthetic division. Okay, so that's always the step number one. Okay, so f of x is the dividend, so we take the coefficients. Okay, so the first coefficient is easy, right? It's 2. Okay, so now, what is the next coefficient? Okay, so here, the point is, there is a reason that we see parentheses around 3 plus 2i. Okay, so don't ever try to distribute x squared. So the next coefficient is 3 plus 2i, because that's what's multiplied in front of x squared, right? And now what's the next coefficient? It's 1 plus 3i. Okay, again, that is something that's multiplied in front of x. And then the last coefficient, it's I. Okay, so we have an imaginary number or imaginary numbers, not just one. Okay, and then the k value is negative I, so that needs to be written outside. Okay, so now at the end of the last class, we saw synthetic division, which involved complex numbers, and it was really ugly. Okay, so will this problem be ugly as well? Well, you'll see. Okay, so first you bring down the 2, and then you multiply this number, so you get negative 2i, right? And now, remember, you are adding these two numbers, so what do you get? You get 3, right? Okay, and now you multiply these two, so you get negative 3i, and then you are adding these two, so you get 1. And then it's negative I, and then 0. Okay, so what do you notice here? Even though we started off with very ugly looking expressions, well, once we apply the synthetic division, all the numbers are really good, right? Okay, and now, again, 0 is the remainder, but is that surprising? No, because negative I was a 0, remember, right? So of course 0 is expected. So instead of looking at the remainder, we look at the quotient. So what's the quotient? It's 2x squared plus 3x plus 1, right? Okay, so that's the quotient spot. Okay, and again, this is a quadratic expression, so you have to always ask yourself, can I factor this? And this is pretty easy to factor compared to the previous one. Okay, so you can verify this, but the q of x is equal to 2x plus 1 times x plus 1. Okay, so I'm not gonna go over the factoring method here once again. Okay, but you should verify yourself either using the quadratic or AC method or the Mustang method that you indeed get 2x plus 1 times x plus 1 as its factor or factors. Okay, so now what do we do? So in the previous problem, what we did was what? So we had this fact here, f of x equals x minus k times q of x plus r. Okay, now here, what is x minus k? Okay, is it x minus I? No, because it's x minus and then negative I, right? Okay, so it's x minus negative I. So what does that mean? It's x plus I, right? Okay, so be careful when your 0 involves the negative sign, okay? And then the quotient, which we have already factored it, 2x plus 1 times x plus 1. And then the remainder was a 0, okay? So that's it. Okay, now, you might say, well, that's not a linear factor because of an I. Well, yeah, but still the powers of x is, or the power of x is 1. Okay, so that is still a linear factor, okay, even though it involves an I. Okay, so now how do you find the zeros? So you set this whole thing equal to 0, right? Because 0 means the x-intercept, so you set y equal to 0, right? Okay, so from here, what do you do? So that means each factor is equal to 0. So you get x equals negative I, negative 1/2, and negative 1. Okay, so are they the answers? No, because negative I was a given 0. Okay, so we don't ever include this as the other zeros. So what are the other zeros? These two. Okay. Okay, so now that's number 2. And now number 3. Okay, so solve x cubed minus 3x squared minus 4x plus 12 equals 0. Given that 2 is a 0 of f of x, which is the left-hand side of this equation. Okay, so here, basically, what are you trying to do? You are trying to solve this, right? Okay, so that is the main problem. But of course, there are some conditions or hints given to you, okay, which is 2 is a 0 of f of x, which is this one. Okay, so that entire thing is f of x. Okay, so now what is the step number 1? So step number 1 is always the same, synthetic division. Okay, so here f of x will be the dividend, right? Okay, which we take the coefficients. So what are the coefficients? 1, and then negative 3, negative 4, and 12, right? Okay, and then we draw this half rectangle. And now there is no divisor here. Are we in trouble? No. And why not? Because 2 is a 0, right? So what does that mean? I have been labeling the 0, the word 0, as the k. So what does that mean? 2 will go outside. Okay. So now do the division. So bring down the 1, and then multiplication 2, and then addition. So that's negative 1, and then negative 2, negative 6, negative 12, and 0. Okay. Now we got a 0 remainder. Is that surprising? No, because 2 was a 0. So of course the remainder has to be a 0. Okay. And so we are looking at what? The quotient, right? Okay, so the quotient is x squared minus x minus 6. Okay, and hopefully you can easily see that this can be factored, right? Okay, so what do you get? You get x plus 2 and x minus 3, right? Okay. And now what do we do? So now we revisit this fact here. F of x equals x minus k times q of x plus r. And what is x minus k? So k was 2. So x minus k would be x minus 2, right? Okay, and then the quotient, x plus 2 times x minus 3, and then the remainder is equal to 0. Okay, so it's that. Okay, so now what do we do? So now we find the zeros, right? Okay, so what does that mean? Set this whole thing equal to 0. Okay, so what do we get? X is equal to 2, negative 2, and 3. Okay, so now here comes the tricky part. Do we cross out this 0 because it was given? And the answer is no, we do not this time. Okay, and what's the reason? Because, like I said before, what is the main goal of this problem? You are trying to solve this equation, right? Okay, that is just the extra part, okay, which didn't have to be given, but of course, the problem was nice to you, so that's why the problem gave you this hint, okay? But your main goal is to solve this equation, okay? So what does that mean? It's all of these numbers. Okay, you are not trying to find the other zeros, okay? Yes, even though it says 2 is a 0, but that's, like I said, the extra part, okay? Your goal is to solve this equation, which you have solved it, so you shouldn't cross out any numbers, okay? So be careful whether you are finding other zeros or you are finding all of the zeros, okay? If the problem is indeed asking you to find the other zeros, then you have to cross out one of the given zeros, but if not, you have to include all of the values, okay? Okay, any questions over these problems? Well, apparently, like, all of you are in muted mode, so you can actually ask questions, but remember, if you have any questions in the meantime, you can always unmute yourself and ask me, even in the middle of the problem, okay? Okay, so now, before we state the next theorem, so remember the definition of a rational number, okay? So I hope all of you have heard the word rational number before, okay? So the rational number include whole numbers, okay? And then decimals and fractions. Now, here, what we will focus on is these two cases, whole number and fractions, okay, not decimals. Okay, so it's mainly this one, the fractions. And it leads to this next theorem, rational zero theorem. Okay, so it goes like this. Suppose f of x has the leading coefficient a. Okay, so now, first of all, what does leading coefficient mean? Okay, so we know what the coefficient is, okay, which is the number in front of x, or x to the some power, right? Okay, but what is the leading coefficient? The leading coefficient is the coefficient of the highest exponent or power term. Okay, so what is an example here? Okay, so what is an example? So for example, let's say f of x is 2x squared minus 3x to the fourth plus 5x minus 7. Okay. So now, in this case, what people often think is the leading coefficient is 2 because that comes first. Okay. But that's not true because what is the highest exponent here? 4, right? Okay. And what is its coefficient? -3, right? Okay. So that is the leading coefficient. LC means leading coefficient. Okay. So your leading coefficient may not be the first coefficient that you see. Okay. So to get the leading coefficient, you first have to find what is the largest exponent, and then its coefficient will be the leading coefficient. Okay. So be careful with that. Your leading coefficient may not come first. Okay. So f of x has the leading coefficient a, and then the pure number term b. Okay, so now going back to this example here, what is the pure number? That -7, right? Okay. So those are the two ingredients that we need. Then the candidates of rational zeros have the form, okay, so let me put this bar here to distinguish the conclusion part of this theorem. So the candidates of rational zeros have the form. So first you put plus minus sign in front, okay, and then remember the word rational means fractional, okay, so you have a fraction here, and what goes to the top or the numerator? Oops. The usual factors of B divided by the usual factors of A. Okay, so that is the conclusion part. Okay, so now here is that on the next page? No. Okay, so now here is another like weird part, which is what? The usual, right? Okay, so why did I say usual here? Okay, so now let me go to the next page and let me write that note on top of the page here. Okay, so far, whenever we see the word factors, what did we say? Okay, so for example, 4 is a factor, means what? It means x minus 4, right? Or I'm sorry, 4 is a 0, so that means x minus 4 is a factor, right? Okay, so here is one definition of a factor, which you probably didn't know in the past. But what have you learned in your past about factors? Okay, so for example, what are the factors of 4? The factors of 4 are what? 1, 2, and 4, right? And that's the factor that you have seen before. Okay, so here in the earlier page, whenever I wrote the usual factors, what do I mean by that? That is the usual definition of the factor, which you already know. Okay, so basically this one is the fancy version of the factor. This one is the non-fancy one, okay, which is the usual one. Okay, so that's what I mean by this. Okay, so it's not like x minus k thing factor. Okay, so these usual factors mean like the definition of the factor that you already know. Okay, so it's the usual factors of the number term b divided by the usual factors of the leading coefficient a. Okay, and then you put plus minus sign in front of this fraction. Okay, so now 2 remarks about this rational zero theorem. So basically what people are confused is what goes to the top and what goes to the bottom of the fraction. Okay, so here is my recommendation. The numerator, which starts with the letter n, means the number term, which also starts with the letter n. Okay, and of course, it means the factors of all the usual factors of the number term. Okay, so the numerator means the number term. So you know what the denominator or the bottom should be. Okay, the leading coefficient. Okay, and this rational zero theorem just gives us the candidates of rational zeros. Why? Because that's what the theorem says, right? The candidates of rational zeros. Okay, then how do you find the actual rational zeros? To find the actual zeros, you have to use the two things. Okay, so first one, you plug in each candidate into X and see if you get what at the end. Zero. Okay, and why is that? Because for some number, and when you plug that into X, and if you get a zero, what does that mean? That is a zero, right? Okay, which means the x-intercept. Okay, and then use the synthetic division. Okay, so now the thing is, if you get lots of candidates of rational zeros, plugging in each number into X, that can be quite a daunting task. Okay, so what is my recommendation here? So my recommendation here is when you plug in the numbers into X or the candidates into X, plug in the smallest number, okay, that's available. And then go to the next smallest and so on. Okay, so if your candidates of rational zeros are like maybe 1, 3, and 10, for example, don't start from the value 10, okay, because the numbers will be fairly large at the end, okay, and even if you get a 0 at the end, it might take some long time to deduce that conclusion. So start from 1, okay, and then maybe 2, and then maybe -1, and so on, okay. So start from the smallest number, and then go to the next smallest, and then so on. Okay, so that's my recommendation when you check this candidate. Okay, so let's look at this these following two problems. So f of x is x cubed plus 5x squared plus 2x minus 8. Part A, find all possible rational zeros. Okay, so again, here, what's the key part? Possible rational zeros, right? Okay, so that means the rational zero theorem. Okay, so now for the rational zero theorem, remember, what do you need? You need two ingredients, which are what? The leading coefficient and the pure number. Okay, and how do you find the leading coefficient? It's the coefficient of the largest exponent, right? Okay, so step number one. What is the leading coefficient? Okay, so to answer this, what do you have to find? What is the largest exponent, right? So here, what's the largest exponent? 3, right? Okay, so what is its coefficient? 1, right? Because of that. Okay, and what is the pure number here? The pure number is, be careful, it's not 8, okay, it's -8, right? Okay, so because of the rational zero theorem, what do you have? So first you have to have plus minus sign, and then the usual factors of b, which is what? The number term, right? Because the number term goes to the numerator, okay? And then divided by usual factors of the leading coefficient, which is 1, okay? So here, what do we have? Plus minus the usual, and I may start to exclude this usual part depending on some problems, but usual factors of -8 divided by usual factors of 1. Okay, so now I guess the bottom part is fairly easy because what are the factors of 1? That's just 1, right? Okay, So that's pretty easy. Now, here is kind of the weird part here. Factors of -8. So what are the factors of -8? Okay, so maybe some of you might think 1, 2, 4, 8. Okay, but those are the factors of just 8, right? Okay, so what does that mean? Does the negative sign here matter when you try to find the usual factors of a number? And the answer is no. Okay, so what does that mean? This is equal to, again, plus minus, the factors of just 8 divided by factors of 1. Okay, so what are the factors of 8 then? We have 1, 2, 4, 8, right? Okay, and then factors of 1. It's just 1, right? Okay, now here comes another tricky part. What does this fraction mean? Okay, so maybe you haven't seen any fractions of this type before. So what does this fraction even mean? So let's look at the top. It's 1, 2, 4, 8, but what does it actually mean? It's 1 or 2 or 4 or 8, right? Okay, and the bottom is 1. Okay, so what does this mean? This means the top can be 1, but the bottom has to be 1, okay, because it's the only denominator, right? And now, can the top be equal to 2? Oh, yeah. So we have 2 over 1. Okay, now, can the top be equal to 4? Yes. So it's 4 over 1. Can the top be equal to 8? Yes. Okay, so basically, what does the comma mean? It's or, right? Okay, it's 1 or 2 or 4 or 8. And then all over 1, right? Okay, so it means this one. Okay, now we can simplify each fraction, right? And what do you get? 1, 2, 4, 8, right? Okay, so what is the answer? The answer is plus minus 1, 2, 4, 8, right? Okay, now the way that this is written is kind of misleading because this kind of looks like what? Plus minus 1, okay, so that's two value, right? 1 and -1. And then 2, 4, 8. Now, is that what this one says? No. It's actually this one, right? Okay, so what does it mean? Plus minus 1, plus minus 2, plus minus 4, and plus minus 8. Okay, so just for the convenience, I wrote plus minus in front of the whole fraction, but that plus minus actually applies to each of the candidates. Okay, so we have to specify like this, because if we just write plus minus 1, 2, 4, 8, then that kind of sounds like it's 1 and -1 and then 2, 4, 8. Okay, there's no -2, -4, and -8. Okay, but that's not the case, right? Okay, so it's plus minus 1, plus minus 2, plus minus 4, and plus minus 8. Okay, so how many candidates or how many possible rational zeros did we get here? It's 8. Do you see that? Okay, because we have 1, 2, 4, 8, and then all of it's negative, right? Okay, so there are 8 possible rational zeros, which is a lot. Yeah, I know, but remember, how many rational numbers are there in the number world? There are like lots of them, right? We cannot even count all of them. Okay, so even though this rational zero theorem may not sound that powerful, it actually narrows down our options a lot. Okay, because from like trillions of rational numbers, we have narrowed down our options to these 8 numbers, which is huge improvement. Okay, so that is A. And now B, find all actual rational zeros. Okay, so now, even though we got these 8 candidates, we don't know which one is the rational zeros. It might be all of them, it might be one of them, it might be some of them, we don't know. Okay, so how do we find the actual rational zeros? Okay, so now going back to this remark here, what did we say? We have to plug in each number into X and see if we get a 0 at the end. And then we'll apply the synthetic division. Okay, and now here, what was my suggestion? Start from the smallest number possible. Okay, and then go to the next smallest and so on. So here, which number is the easiest number that we can start with? It's 1, right? Okay, and the next easiest number is what? -1, right? Okay, and then 2 and -2 and so on. Okay, so start from x equals 1. Okay, so we plug that in to f of x. And remember, what is f of x? It's this one, right? X cubed plus 5x squared plus 2x minus 8. Okay, so now when you plug in x equals 1 to here, what do you get? It's 1 cubed, and then 5 plus 1 squared plus 2 times 1 minus 8. Okay, so 1 cubed plus 5 times 1 squared plus 2 times 1 minus 8. And now, what is this number equal to? So 1 cubed, so that's 1, right? And then 5 times 1 squared, so that means 5 times 1, so that's just 5. And then plus 2 minus 8, right? And what is this number equal to? That's 6 plus 2, so that's 8 minus 8, so that's a 0. Oh, now, is that a good sign? Oh, yeah. Okay, so that is a really good sign. Why? Because what does that mean? 1 is a 0, right? Okay, so 1 is a unactual rational 0. Okay, and remember earlier I said rational can be a whole number, so there we go. Okay, now, do we plug in the next number -1? And then -2, or 2, and then -2, and so on. Well, you can do that, yeah, but here, what's the problem? You'll be plugging in the number, how many times? 8 times, right? Okay, and that's just too tedious. Okay, now, is there any smart approach? Oh, yes. What is the smart approach? Synthetic division. Okay, so basically, once you find a0, you stop and you don't plug in other numbers and you apply the synthetic division right away. Okay, how? F of x becomes what? The dividend, right? And here, even though we are not given a z or the divisor, can we still find out what goes to the outside of the half rectangle? Yes, that will be the k value, right? Because it's a 0. Okay, so for f of x, we take coefficients. So what are the coefficients? 1, 5, and then 2, and then -8. Okay, and then the 1 is written outside. Okay, so what do we have? Bring down the 1, and then multiplication, addition, multiplication, addition once again, multiplication, and then addition. Okay, so now 0 is the remainder, but that's not surprising at all because 1 was a 0. Okay, so instead what we are looking at is what? The quotient, right? Okay, so here, what is the quotient? The quotient is x squared plus 6x plus 8. Okay, now, this is a quadratic expression, so can we factor this? And the answer is, oh yes. Okay, so what do we get? X plus 2, x plus 4, right? Okay, so now what do we do? So remember we had this earlier fact here, x minus k times q of x plus r. Okay, so here k was 1, remember, k was 1. Okay, so x minus k would be x minus 1. Okay, and then the quotient is x plus 2 times x plus 4, and the remainder was 0, so it's just that, right? Okay, and now, how do you find the actual rational zeros? So to find the zeros, what do you do? Set this whole thing equal to 0, right? Okay, so what do you get? X is equal to 1, -2, and -4. Okay, and here, be careful. The problem didn't say find the other zeros, right? Just find all actual zeros. Okay, so what does that mean? It's all three. Okay, so 1, -2, and -4 are the actual zeros. Okay, so now that was part B, and then part C. There's part C on the next page. Okay, so now what does part C say? Part C says factor f of x into linear factors. Okay, now wait a minute. Have we done this before? Like 10 or 20 seconds ago? So go back to part B. Have we factored f of x into linear factors? Oh yeah, we did right here, right? Okay, so what do we do? Just copy what we already got. X minus 1, x plus 2, x plus 4. Boom, that's what we have. Okay. So you can see that the process of getting our answer to one problem, okay, within that process, it may contain the answer to another problem. Okay, so everything is kind of like interwoven. Okay, like it really closely related. Okay, so that's part C. And now number 5. Find all possible rational zeros for f of x, which is 15x cubed plus 61x squared plus 2x minus 8. Okay, now notice that here I only said find all possible rational zeros, not the actual ones, and you'll see why. Okay, so here to find all possible rational zeros, what do we need to find? The leading coefficient and the number term, right? Okay, so here, what is the leading coefficient? And now, remember, to find the leading coefficient, you first have to find the largest exponent, right? Which is equal to 3, okay? And whose coefficient is 15, right? And then, what is the pure number term? That's -8, right? Okay? And now, because of the rational zero theorem, what do we have? We have plus minus in front. And then the usual factors of -8, the number term, divided by usual factors of 15, right? Okay, and remember, whenever you're finding the usual factors, that negative sign doesn't really matter, right? So what does that mean? This will be the same thing as just 8, right? Okay, same thing as finding factors of 8. Okay, so what do you have? Plus minus sign, and then 1, 2, 4, 8. And then factors of 15. What are the factors of 15? It's 1, 3, and then 5 and 15, right? Okay, so now we have apparently complicated looking fraction here. So what does this even mean? Okay, so we have 4 options at the top and same thing at the bottom, right? Okay, so let's see. Let's say the bottom was 1. Okay, then we have 4 options at the top, right? Okay, so basically, what does it mean? it can be 1 over 1. Okay. Now, can it be 2 over 1? Yeah. 4 over 1 and 8 over 1, right? Okay. Now, let's change the candidate for the denominator, which is 3. Okay. Then we also have these 4 cases at the top, right? So we have 1 over 3, 2 over 3, 4 over 3, and 8 over 3. Okay, so now hopefully you can see the pattern. Go to the next candidate at the bottom, which is 5, and then we have 1 over 5, 2 over 5, 4 over 5, and 8 over 5. Okay, and then the last candidate for the bottom, 15. So 1 over 15, 2 over 15, 4 over 15, and 8 over 15. Okay, so this fraction means this. Okay, and then what do you have? In front of this whole thing, you have plus minus, right? Now, you can see that the only 4 fractions that can be simplified are what? The first 4, right? For every other things, you can verify that you cannot simplify or reduce any of them. So what is the answer? The answer is plus minus 1, plus minus 2, plus minus 4, plus minus 8. Okay. And then here, let me be a little bit sloppy. It's plus minus all of that. Okay. Okay, so here again, I'm being kind of sloppy, but it's plus minus 1/3, plus minus 2/3, and so on. Okay, so that's the answer. So this time, how many candidates did we get? Okay, so it's 1, 2, 4, 8, and then all of these, right? So what does that mean? There are 16 numbers here. There are 16 numbers here. But then there are 2 options for plus minus, right? So what does that mean? 16 times 2, so that's 32 possible candidates. Okay, well, which is, yeah, insane, I know. And that's why, I didn't include, like, find the actual zeros here. But you may still say, well, 32 candidates is a lot. Yeah, it's a lot, but it's, again, way better than like trillions of rational numbers. Okay, we have narrowed down to 32 numbers only. Okay, which is not too terrible. Okay, so, okay, any questions over these rational zero theorem? Okay, so now we are halfway there. And now here is the next theorem, fundamental theorem of algebra. Okay, so now in math, there are a few fundamental theorems. There is fundamental theorem of arithmetic, and then there's fundamental theorem of calculus, and then there's this fundamental theorem of algebra. Now, any fundamental theorems in math are, first of all, fun. Woohoo. Okay, and it's fun in where? In your mental. Okay, and now in the middle you have dA. Okay, it's not do. Okay, it's not do. Okay, it's more like do. And for those who have taken French before, you will know that the word do means like of, right? Okay, so it's like fun of mental. Okay, anyways, but that's not the point. And I frequently abbreviate this fundamental theorem of algebra as FTA. It's not free trade agreement. Okay, present between like US and Canada and US and Mexico and things like that. There's no trade here. Okay, so it's just FTA, and it's just a notation. Now, it goes like this. Every polynomial function f of x has at least one real or complex zeros. Okay, so what? So this is actually not that important. What's important is this extra note from this FTA. So such polynomial function f of x can be written as, so here I have to be a little bit careful. So a times, and then let me put this square bracket here, product of the factors x minus k. Okay, and here, in other words, this means x minus each 0. Okay, so now this is kind of sloppy notation, but I frequently use this because this kind of makes sense to most people. Okay, instead of like using all the fancy notations in math. Okay, so now this expression looks complicated, but it's actually not that bad. So what does this expression say? First, you have to find each 0, okay, which is what, k, right? And then you subtract each 0 from x. And what is the name of this x minus k? It's the factor, right? I mean, the fancy version of the factor. Okay, so that's why here I said factors. And now, once you find the factors, what are you doing with them? You are multiplying those factors. Okay, and in front of this product of the factors, what do you have? This a. And now, what does that a represent? It is the leading coefficient. Okay, and this leading coefficient will be either given in a problem or you can find it in a problem. Okay, so of course, if it's given, you have huge advantage, but sometimes it may not be given, okay? But there will be an information that you can use it to find the leading coefficient, okay? So in other words, once again, the FTA states that leading coefficient times the product of the factors x minus each 0. Okay, so first you have to find the 0. And then from here, you have to find the factors, multiply them all together, and then multiply the leading coefficient in front. Okay? Now, here is another sad and depressing news. Multiplying these linear factors, x minus k, is not enough. Why? Because you have to FOIL at the end completely. Okay, and unfortunately, that's what the problems will ask you to do as well. Okay, now before we do any problems, let me state another things. The multiplicity of a 0. Okay, now back in chapter 1, I think I briefly mentioned the multiplicity, but maybe you don't remember or you just forgot. Okay, now the multiplicity means the number of copies or repetitions. Now here's my typo, but that's not a big deal, of the corresponding 0. Okay, so here's an example. Suppose we have x squared minus 2x plus 1 equals 0. Okay, so now you can factor this and get x minus 1 times itself, right? Now, here, what is the answer? It's x equals 1, right? and 1, of course, but we don't write 1 twice, right? So we just write x equals 1 once. Okay, however, the fact is what? We got 2 1s, right? We didn't get just 1 once. Okay, so here, even though the answer is 1, what is the multiplicity of 1? The multiplicity is equal to what? 2, right? Why? Because we got 2 copies of 1. Okay, so that's what the multiplicity means, the number of copies of each 0. Okay, now here, look at this x minus 1 times itself. You can rewrite this into x minus 1 quantity square, right? Okay, now from this expression, can you deduce where you can find the multiplicity, which is equal to 2? So in other words, where do you see the 2? It's in the exponent, right? Okay, it's in the exponent. So what does this imply? To find the multiplicity, okay, look at the exponent of the factor where the 0 is from. Okay, so here I didn't say it, but to find the multiplicity, we need to look at the exponent of the factor, but that's actually stem number 2. What is stem number 1? It's this. Okay, factor f of x first. Okay, what so many people do is, oh yeah, we just look at the exponent. Okay, but they don't check this one. Okay, whether f of x is factored. Okay, so before you look at the exponent of something, you have to check whether f of x is factored. If it's not factored at the beginning, what do you have to do? Oh, factor it. Okay, factor f of x. Okay, so if f of x is not factored, or if we don't have factors, then you need to factor f of x first and then conclude the multiplicity. If it's not factored, then you cannot conclude anything about the multiplicity. Okay, so let's look at the next problem, number 6. For each, find all zeros and find their multiplicities. Okay, so part A, f of x equals 5x squared times x minus 1 cubed times x plus 1 squared. Okay, you can read it. Okay, so now here, do we have to FOIL this entire thing? Okay, and what do you think the answer is? Okay, please don't. Okay, because if you FOIL, guess what you have to do? Come back to this step. And good luck with that. Okay, and I don't think even me, I don't know how to factor this into this. Okay, like, you know, like once you FOIL it, like I don't know how to come back to this step. Okay, so don't ever FOIL. That's not the point of this problem. Okay, so first, let's find all zeros. Okay, so how do you find the zeros? Set this whole thing equal to 0, right? Okay, so now most people, okay, most people get x minus 1 equals 0, okay, because of that, right? And then x plus 1 equals 0. And then this. And then this. Okay, now, here is my question. Do we set that equal to 0 as well? And the answer is yes, we do. Okay, why? Because even though this 5x squared is not within the parentheses, what is the important thing here? It contains x. Okay, so even if something is not within the parentheses, if that contains x, you have to set it equal to 0. Okay, you must. Okay, so be careful with that. Most people forget about this equation, but you shouldn't. Okay, so now let's look at this top equation. So first, what do? Divide by 5, right? So x squared is equal to 0. Okay, so x is equal to 0, right? By taking the square root, right? Okay, and now from here it's pretty easy. X is equal to 1, right? And from here, x is equal to -1. Okay, and now from here, what do? You add 4, so it's x squared equals 4. And then you take the square root. Okay, and so what do you get? X is equal to 2, right? Right? Are we missing something? Okay, we are missing what? That, right? Plus minus sign. Okay, and then from here, x is equal to what? 10, right? Okay, so what are the zeros here? It's 0, 1, -1, 2, -2, and 10. Okay, so these are the zeros. And now, how do we find their multiplicities? Okay, so remember, to find the multiplicities, we need to check two things, right? Which is what? Is f of x factored? And if so, we look at the exponent. Okay, so now, was f of x factored? Yes. Okay, this one was factored from the beginning. Okay, so now we can just look at what? The exponent, right? Okay, so now to look at the exponent, we don't look at the exponent of f of x. Okay, be careful. We look at the exponent of the factor. Okay, not the entire function f of x. Okay, so what is the multiplicity of a 0? So multi means multiplicity. So the multiplicity of 0 is what? 2. And what's the reason? 0 came from this, whose exponent is 2. And now, what is the multiplicity of 1? Okay, so now where did 1 come from? So 1 came from x minus 1. And x minus 1 came from what? X minus 1 cubed, right? So what does that mean? It's multiplicity 3. Okay, so what does that mean? There will be 3 copies of 1, right? It's 1, 1, 1. And then for 0, we have 0, 0. There are 2 copies, right? And what is the multiplicity of -1? So -1 came from where? X plus 1, right? And x plus 1 came from where? X plus 1 squared, whose exponent is 2. Okay? And now, plus minus 2. Where did they come from? X squared minus 4, right? And its exponent is what? 2, right? Now, does that mean the total multiplicity is 2 or each multiplicity is 2? It means each multiplicity is 2, right? So each multiplicity is 2. Okay, not total, right? So there are 2, 2, and then -2 and -2. Okay, it's not 2 and -2. Okay, it's 2, 2, -2, -2. Okay, so each multiplicity is 2. And now, where did 10 come from? 10 came from x minus 10. And what is its exponent? It's missing, so is that 0, or does that mean it's equal to 0? No. X minus 10 to the what power? First power, right? So what does that mean? Multiplicity is 1. Okay, and now what does 1 multiplicity mean? It means there's only one copy, right? So it's just 10. And there's no second or third copies, right? Okay, so those are the multiplicities. Okay, so now that is A. And then B. F of x is equal to negative 2x to the fourth plus 2x cubed plus 24x squared. Okay, so now here is the multiplicity, or are the multiplicities equal to 4, 3, and 2, the exponents? No. And why not? Why not? Even though we look at the exponents, remember, what do we first have to verify? Is f of x factored? If not, you have to factor it first, right? Okay, so here, what must be the step number 1? Factor f of x. Okay, that must be the first step. And now here, let's see, how can we factor this? So can we pull out something? Okay, so can we pull out something? So here, what is the GCF? Okay, so here the GCF is, I guess most people can see that you can pull out the 2, right? And also x squared. Now, can you pull out once more? Or like one more? The negative sign. Okay, so let's see what happens when you take out negative 2x squared. So what do you get? Negative 2x squared times just x squared. And then we have minus x, right? And then what's next? Minus 12? Okay, and now, can this be factored further? Yes, so what do you get? Negative 2x squared times x plus 3 times x minus 4, right? Okay, so there we go. We have negative 2x squared times x plus 3 times x minus 4. Okay, so now what do we have? So that is equal to f of x, right? Okay, and now can we find the zeros? Okay, so to find the zeros, what do we do? So x plus 3 is equal to 0. Okay, because this whole thing needs to be set equal to 0, right? And then x minus 4 equal to 0. And now what about negative 2x squared? Do we also set it equal to 0? Yes. Okay, be careful. As long as when something contains an x, you need to set it equal to 0, even if that's not within the parentheses, right? Okay, so now from here, what do you do? First, you divide by negative 2, right? So x squared is equal to 0. So x is equal to 0. Okay, and then from here, it's x is equal to negative 3. And then from here, x is equal to 4, right? Okay, so what are the zeros? These are the zeros, right? Okay, and now what is each multiplicity? Okay, so multiplicities. So multiplicity. So what is the multiplicity of a 0? So 0 came from negative 2x squared, right? Okay, and again, be careful. The multiplicity of 0 is not 4, okay, or 3, okay, or even this 2, okay. You don't ever look at the original exponents to find the multiplicities unless that is factored, which is not, right? Okay, so the multiplicity of 0 is what? That, right? Which is 2. Okay, so the multiplicity is 2. And now what is the multiplicity of -3? So -3 came from x plus 3, whose exponent is what? 1, right? And what is the multiplicity of 4? So 4 came from x minus 4, whose exponent is also 1, right? Okay, so it's 2, 1, and 1. Okay, so again, before you factor f of x, you cannot conclude anything about the multiplicity, okay? So if f of x is not factored, you need to factor it first, and then find the zeros, and then find the multiplicities, okay? And once you factor f of x, you don't ever look at the original f of x, okay? So this one is gone, okay? Okay, so any questions over these two problems? Okay. So now, let's look at number 7, okay? So now, the number 7, which has two parts, and number 8, which is on the next page, these two will be very technical and lengthy, okay? So this is a kind of warning. So, find a polynomial f of x of degree 3. Okay, so now here we see a word that maybe you haven't heard before. So we will, or I will mention what the degree means in the next section, but the degree means the largest exponent. Okay, so basically the largest power has to be 3 for f of x. That satisfies the given conditions. Part A. Zeros are -3, -2, and 5. Each multiplicity is 1, and f of -1 is equal to 6. Okay, so now here, what can we do first? So we know the zeros. Okay, now some people tend to say we'll use the synthetic division. But what's the problem? We don't know what the equation of f of x is. So we cannot apply the synthetic division because we don't know what the dividend is. Okay, so what can we do first? So we know the zeros. And now from zeros, can we get something? Yes, the factors. Okay, so step number 1 is find the factors. Okay, not the usual definition of the factor, but the fancy one. Okay, so for -3, so remember, given a 0, how do you find the factor? It's x minus k, right? So what does that mean? X minus -3, right? Okay, so that's how you find the factor of -3. And now what about -2? Its factor is what? X minus -2, right? Okay, and then for 5, its factor is what? X minus 5, right? Okay, so in short, what are the factors? X plus 3, x plus 2, and x minus 5. These are the factors. Okay, and now what is the step number 2? So let's go back to about 2 pages ago. Okay, so now the fundamental theorem of algebra, or FTA, says for each 0 we get a factor. And now what do we do with these factors? We multiply them, right? Okay, and followed by the leading coefficient a. Okay, so due to the FTA, fundamental theorem of algebra, what do? We multiply these 3 factors. Okay, so in other words, f of x is equal to x plus 3, and then times x plus 2, and then times x minus 5. And followed by a, the leading coefficient. Okay, so basically we have used this info. Now, we haven't used each multiplicity being equal to 1. So how can we use that? So remember, the multiplicity comes from the exponent of a factored form. So this one is a factored form, right? Okay, and what does that mean? The multiplicity or the exponent of x plus 3 has to be 1. Same thing for x plus 2 and same thing for x minus 5, right? And now, are these exponents be equal to 1? Yes. Okay, so by just looking at this, we have used this information as well. Okay, so now we haven't used this info yet. So how can we use that? So that will be used to find the A, the leading coefficient. So remember, I said before, either leading coefficient A will be given in a problem or you have to find it. Okay, so here it's not given, so you have to find it. Okay, so step number 3, find A. Okay, and here we use f of -1 is equal to 6. Okay, so now what does that mean? F of -1 equals 6. So that means when x is -1, y is equal to 6, right? Okay, so what do you have to do? Plug in x equals -1 and then set it equal to 6, right? Okay, at the end, of course. Okay, so what do you get? So once you plug in x equals -1 into here, what do you get? It's a times -1 plus 3, and then times -1 plus 2, and then times -1 minus 5, and then this whole thing is equal to 6, right? Okay, so now what is this number? That's 2, that's 1, that's -6, right? Okay, that's -6. And now you're multiplying 2, 1, and -6, right? So what does that mean? It's -12, right? So -12a is equal to 6. Okay, so what do you get? So by dividing by -12, a is equal to what? -1/2, right? Okay, so f of x is equal to -1/2 times x plus 3 times x plus 2 times x minus 5. Okay, so now we found the f of x. So are we done? And the answer is no, we are not, unfortunately, because of what? What do we have to do? Foil it at the end. Okay, so the problem is, even though this is right, and suppose this was the problem in the homework or a problem in the homework, and if you put that as the answer, MLP will say your answer is wrong. Or it will say, yes, it's okay, but you have to foil it, which is wrong. Okay, it's not what MLP wants. Okay, so you must foil this completely. Okay, so step number 4, foil this. Okay, now, the foiling of this long expression can be really scary because people usually start from, oh, distribute to -1/2, and then foil it, and then foil it once again. Okay, so here's my suggestion to make your lives a little bit easier. So first, foil this, x plus 3 times x plus 2. Okay, so first foil this. And then number 2, foil this. And then take care of -1/2 at the very end. Okay, so now x plus 3 times x plus 2. Is that easy to FOIL? Oh yeah. So what do you get? X squared, and then plus 2x plus 3x, so that becomes plus 5x, right? Plus 6. Okay, and now what do you have? X squared plus 5x plus 6, and then times x minus 5, right? Okay, so now foiling of this one is kind of tedious, but it's not too terrible, right? So what is this? X cubed, and then minus 5x squared, right? And then these two plus 5x squared, and then these two minus 25x, and then what is next? This one plus 6x, and then these two minus 30, right? Okay, now combine like terms. So these two cancel, and so you have x cubed minus 19x minus 30, right? Okay, so now we are done with foiling this part. So now what do you have to do? Times negative 1/2 in front, right? So what does that mean? It's, let me go to here. So now we have negative 1/2 times x cubed minus 19x minus 30, right? Minus 30, okay? So what is this? Distribution, okay? So what do you get? Negative 1/2 x cubed. And now it's negative 1/2 times negative 19, right? So what does that mean? It's plus 19 over 2 and then x, and then negative 1/2 times negative 30. So what does that mean? It's 30 over 2, right? Which is what? Plus 15. So that is the answer. Okay, so that is what you have to put if this were a problem in the homework. Okay, not this. Okay, and you can see why I said this problem is very technical. Okay, so now that's A, and then B, and then B. 4 is a 0 of multiplicity 3, and f of 2 is equal to negative 24. Okay, so now here, first what do we do? What we do is, we'll do the same thing, find the factor. Now here, 4 is a 0, right? So what does that mean? It's x minus 4, right? And now, are there any other factors? No, because there was only one 0, right? So there's only one factor. Okay, so because of the fundamental theorem of algebra, what do we have? F of x is equal to the leading coefficient a times x minus 4. Now, the question is that it? No, because we have used this info, but we haven't used this one yet, right? So the multiplicity is equal to 3. So what does that mean? The exponent of x minus 4 has to be 3, right? Okay. And now, how do we find the leading coefficient a? Well, so there's yet another information that we haven't used, which is this one, right? F of 2 is equal to negative 24. Okay, so what does that mean? We plug in x equals to 2, and then we set it equal to negative 24 at the end. So what do you get? A times 2 minus 4 cubed is equal to negative 24, right? Okay, and now let's look at the left-hand side. So here you take care of the exponent first. So that's negative 2 cubed, which is equal to what? Negative 8, right? So we have negative 8a is equal to negative 24. So a is equal to what? Positive 3, right? Okay, so f of x is equal to what? 3 times x minus 4 entire thing cubed, right? And now, just like before, that's not the final answer, right? Because you now have to FOIL this. Okay, so now you have to FOIL this. Now, you know you are doing the exponent first, but is this equal to x cubed minus 4 cubed? No, right? Okay, so how do you FOIL this? So first you write this as x minus 4, x minus 4, x minus 4, right? Okay, you have to write it out, right? And then what do? You basically do what we have done before, right? Which is what? This one first, and this one next, and then that one is the last step, right? Okay, so x minus 4 times x minus 4. So now what is this? X squared minus 4x minus 4x, so that's minus 8x, and then plus 16, right? And then step number 2, you have x squared minus 8x plus 16 times another x minus 4 at the end. So what is this? X cubed minus 4x squared minus 8x squared plus 32x, and then plus 16x, and then minus 64. And so what is this? X cubed minus 12x squared, and then plus 48x minus 64. Okay, and now, what do we have now? 3 in front, right? So now you have to distribute 3 to each of the terms, right? So what do we have at the end? So you have 3x cubed minus 36x squared. And now 3 times 48, what is that? 144. So 144x. And then 3 times 64. So that's what? 192 minus 192. Okay, so that is the answer. Okay. Any questions over this problem number 7? Okay, so now there is one last remaining theorem. So the textbook does not mention about the specific names of these two theorems. So I just call them IN square root theorems. Okay, and it goes like this. If a plus bi is a 0 of f of x, then a minus bi is also a 0. Okay. Okay, sorry about that. So now, a plus bi is a 0 f of x, then a minus bi is also a 0. Now, have we seen the relationship between a plus bi and a minus bi before? So what's the difference? We only changed the middle sign, right? And do you remember what was the name of such phenomenon? Flip the middle sign only.
Conjugates?
The conjugates, yes. Okay, so the conjugates. Okay, so if a plus bi is a 0, then its conjugate is also a 0. And now, similarly, if a plus square root of b is a 0, then a minus square root of b is also a 0. And what's the difference here? Again, we only switch the middle sign only. So it's also called the conjugate. So sometimes people say these two are the conjugate theorems, but this conjugateness only makes sense for the in square root only, okay? Now, what does that mean? For example, suppose 5 is a 0 of f of x. Does this mean -5 is also a 0? Because when you switch the sign of 5, you get -5. And the answer is no, okay? So this conjugateness does not apply to the whole numbers, okay? So 5 is a 0 f of x. Sure, -5 can also be a 0, but if that's the case, that will be given, okay? It's not something that you can deduce, okay? So 5 is a 0 does not mean -5 is also a 0. That might be the case, but it will be given in a problem. Okay, whereas for these two, the square root and I, or square root and the I theorems, you can deduce these two hidden zeros. Okay, so these two will be the hidden zeros. Okay, oops, hidden, which you have to find or deduce from a problem. Okay, so now let's do two problems, and then I guess that should be it for the day. Which is on the next page. Okay, so now find a polynomial f of x which satisfies the given conditions. Part A, leading coefficient is 1. Zeros are 5, -5, and -7i. Each multiplicity is 1. Okay, so now if you thought problem number 7 was technical and the most difficult one within the section, this one will be the ultimate problem, especially part B, and you'll see why. So first, we have zeros that are given, okay? So what did we do in problem number 7 as the first step? Find the factors. Okay, so first find the factors. So the first 0, 5. So that means x minus 5, right? And then from the second 0, -5, to get the factor, we subtract -5 from x, okay? And now, for the third 0, -7i, we subtract it from x as well. Okay? Now, are we done? And the answer is no, because is there any hidden 0? And what is the hidden 0? So let's find the hidden 0 here. So -7i is a 0. So what does that mean? Its conjugate, +7i, is also a 0. So what is the hidden factor? The hidden factor is what? X minus 7i, right? Okay, which came from the hidden 0, 7i. Okay, so in summary, what are the factors? The factors are x minus 5, and then x plus 5 from here, and then x plus 7i, and then this one, x minus 7i. Okay, so these are the 4 factors. Okay, so once again, you should not conclude these 3 are the factors, okay, because there is a hidden 0 which you can get another hidden factor. Okay, and now what do we do? The fundamental theorem of algebra. So FTA says f of x is equal to a times the multiplication of these 4 factors, x minus 5, x plus 5, x plus 7i, and times x minus 7i. Okay, and now the leading coefficient is 1. What does that mean? So are we in a better situation than before? Yeah, because that is 1, right? Okay, so each multiplicity is 1. What does that mean? Each of these exponents will be equal to 1, right? Okay, so we are also in a better situation as well. Okay, so we have used all of it, actually. Now, for these I square root theorem problems, my recommendation is whenever your factors involve I and or square root, okay, so let me go up a little bit. Whenever your factor, oops, sorry. Okay, so whenever your factor involves I and square root, write the I factors and square root factors right next to each other, side by side. Okay? So what does that mean? You can write x minus 5 times x plus 7i, and then times x plus 5 and x minus 7i, and still get the same thing at the end. But my recommendation is write the I factors and the square root factors right next to each other. Okay, so that's my first recommendation. And then my second recommendation, use the difference of squares. Oops, difference of squares. Difference of squares to FOIL these. Okay, so now what does that mean? The difference of squares. So it's a plus b times a minus b is equal to what? A squared minus b squared, right? And all of you have seen this formula before. Okay, so to FOIL I and square root factors, so first write them side by side, and then 2, use difference of squares. And you'll see why this one will reduce your work by a lot. Okay, so these are my suggestions. And now let's now FOIL this. Okay, now normally when you FOIL, you'll go from left to right, but no, here's my suggestion. FOIL this one, and then step number 2, FOIL this, and then step number 3, FOIL in the middle. Okay, and you'll see why. So first, x minus 5 times x plus 5. Now, you can FOIL this in a standard way, but notice that this is same thing as the setup of the difference of squares, right? So what do you get? X squared minus 5 squared, or minus 25, right? Okay, and now, number 2, x plus 7i times x minus 7i. Okay, so now, again, this is a difference of squares, right? So what do you get? X squared minus 7i entire thing squared. Okay, and what is this? So this is x squared minus 49i squared. Okay, and remember, what is I squared? It's -1, right? So what do you get? X squared plus 49. Okay, so what do you have? Now you have x squared minus 25 for this one, and then times x squared plus 49 for these two. Okay, and now what do you notice here? That's just the standard FOIL. And moreover, you have another huge advantage. And what is that? There's no I, right? You had I in your f of x at the beginning, but after using the difference of squares here, there's somehow no I. And that's the beauty of writing those I factors side by side and using the difference of squares. Okay, so what do you get? So x to the 4th and then plus 49x squared, and then minus 25x squared. Okay, so those are pretty easy. And now 25 times 49. Okay, so 25 times 49, oops, times 49. So what is this? 5 here, 4, so that's 225, and then 2, so that's 100, right? And then you add, so you get 1225 with the negative sign, right? Okay, but there's a like term here, so x to the fourth plus 24x squared minus 1225. Okay, so that is the answer. Okay. Now, even though it's past noon, let's finish off this last problem of the section, okay, so that we can start the new section tomorrow. Okay, so now, leading coefficient is once again 1, and the zeros are 1 plus square root of 2, multiplicity is 1, and 2 minus I, whose multiplicity is also 1. Okay, so now, what is the stem number 1 here? So I think we can find the hidden zeros, right? Because we have the square root and the I. Okay, so let's start with the square root part. So how do you find its hidden zero? So you have to find its conjugate, right? Which means what? You have to flip the middle sign. Okay, and for 2 minus I, its hidden zero is what? 2 plus I, right? Okay, so now, what are the factors? Okay, so for the first zero, which is 1 plus square root of 2, okay, what is its factor? It's x minus 1 plus square root of 2, right? Not quite. And what is the reason? Parentheses. Okay, so now why do we need parentheses? Because if we don't, it seems like, oh, we subtract 1 from x and then we add square root of 2 at the end. But that's not what we are doing, right? What are we doing? We are subtracting this quantity 1 plus square root of 2, which is a 0 from x. So we need parentheses. Okay, and now the second 0, 2 minus I. So what does that mean? X minus 2 minus I, right? And again, do we need parentheses here? Oh, yes, because we are subtracting the quantity 2 minus I from x. Okay, so hopefully you can see the pattern here. So the next 0, 1 minus square root of 2. So it's x minus parentheses 1 minus square root of 2. And then for the last 0, 2 plus I, it's x minus parentheses 2 plus I. Okay, so now let's clean things up. So what are the factors? X minus 1 minus square root of 2 by clearing parentheses. And then x minus 2 plus I. And then x minus 1 plus square root of 2. And then x minus 2 minus I. Okay, so these are the factors. Okay, so once we need parentheses, we can clear them and get the correct factors. And now, what is the next task? The fundamental theorem of algebra. Okay, so what does that mean? We need to multiply these 4 factors, right? Okay, so now, the problem says the leading coefficient is 1. Are we in a good situation once again? Yes, because that means what? The number in front here will be 1, right? Okay, so that's a really good sign. And also the multiplicities are 1. Okay, so what does that mean? So the exponent of, let's see, this and this will be 1, right? Now, does that mean the multiplicities of the hidden zeros be also equal to 1? Oh, yeah. Okay. So what does that mean? We can just like multiply these four things, right? Okay, so f of x is equal to x minus 1 minus square root of 2, and then x minus 2 plus I, and then x minus 1 plus square root of 2, and then x minus 2 minus I, right? Okay, so now this is fine, except what? So remember, what was my previous recommendation? Write the I factors and the square root factors side by side. So what does that mean? Although this is correct, we can rearrange them and write this into first x minus 1 minus square root of 2, and then x minus 1 plus square root of 2. Okay, so basically flip these two, okay, like this. And then we have x minus 2 plus I, and then x minus 2 minus I. Okay, then we have the square root of, or square root factors and the I factors side by side. Okay, and now we can FOIL this. But what is my suggestion? Well, do the same thing as before. FOIL this first, this second, and in the middle, last. Okay, so now, we know that we have to somehow use the difference of squares. Okay, so let's look at this first factor here, or the first product. Okay, so now we FOIL. So number one, x minus 1 minus square root of 2 times x minus 1 plus square root of 2. So now here, we have to use the difference of squares, but you can see that it's kind of complicated compared to the previous setup, right? So now here, remember what we need is a minus b, and then so something minus something times something plus something, right? Now, can you see that something minus something times something plus something here? So in the previous problem, that something was what? Just x, right? Same thing here and same thing here. Now, is x need to be squared or something else needs to be squared? And this is kind of tricky, but look at this form closely. Where do you see something minus something times something plus something? That, and that, right? It's x minus 1 minus square root of 2 times x minus 1 plus square root of 2. Okay, so what needs to be squared? It's not x, right? It's x minus 1 needs to be squared, and then minus square root of 2 squared. Okay, so this is kind of tricky, as you can see. Okay, so now what do you get? So this one you must FOIL it, right? So you get x squared minus 2x plus 1. And then what is square root of 2 squared? So that's just 2, right? So it's just minus 2. And so you have x squared minus 2x minus 1. Okay, so we did a hard part. So hopefully you can do how to FOIL this second product, okay? So second product is x minus 2 plus I, and then times x minus 2 minus I. So now from here, do you see something plus something times something minus something? It's this one, right? Okay, so what needs to be squared first? It's x minus 2 squared, and then minus I squared. Okay, so it's again tricky thing here. So you FOIL this, and you get x squared minus 4x plus 4. And remember, I squared is negative 1. So it's minus negative 1, so that's plus 1. And so you get x squared minus 4x plus 5. Okay, now the last step is what? Multiply these two things and then FOIL once again, right? So we have x squared minus 2x minus 1, times x squared minus 4x plus 5. Okay, so now we just have to follow this, and we are almost there. So first, it's this times this, and then these two, so it's minus 4x cubed, right? And then these two, so it's plus 5x squared. And then these two, so that's minus 2x cubed. And then these two, so that's what, plus 8x squared. And then these two, so that's minus 10x. And then go inside, so that's minus x squared plus 4x, and then minus 5, right? Okay, it was kind of long, but it's not too terrible, right? And now you just have to combine like terms. So this, and then this, and this, and then these two, right? Okay, so what do you get? X to the fourth minus what? 6x cubed. And then plus 12x squared. And then what? Minus 6x. And then minus 5. Is that right? Yeah, up here so. Okay, so that is the answer. Okay, so thanks for staying overtime. Okay, and now tomorrow we will do 3.4. So 3.3. So like I said at the beginning of the class today, 3.3 is an insane section. Okay, it's really, really challenging. So if possible, I recommend strongly to re-watch this recorded video of today's lecture, okay, for those who came in late or for those who were not present in today's meeting, and then understand yourself, okay, because this is not trivial. Like I said, this is the most difficult section of the course, okay, but all of them are important. Okay, so please understand today's lecture completely. Okay, and today or no, tomorrow we will do 3.4, and then we will go all the way to the end of chapter, which is chapter 5, and then we will cover some easy ones.